Visualize yourself on this plotting journey, which begins right now. All right, we're out here in Jupyter Hub, and you can see there's a lot of imports happening here. We have Matplotlib, which is a plotting library that has a similar API to MATLAB. We have Plotly's Chart Studio and Plotly Express. We're using Pandas, of course, for building our data frames, and Folium for maps. And we have Matplotlib in line. This percent is what's called a Jupyter directive. This directive forces the plots to occur within the notebook frame. This is the default, by the way, in the way Jupyter Hub has been set up, the one that we use. But I like to include it in here in case you're using these notebook files outside of the Jupyter Hub that I set up for you. Okay. So let's talk about what we're doing here. So we have this basic data set on moviegoers, and it has information about people that go to the movies, their age, their gender, their occupation, where they live, and if they're, an adult, what kind of ticket they bought, adult or a senior ticket or a child ticket. And we're going to analyze this data with charts and graphs and maps. Okay, so these things we've seen before. This is all stuff from the Pandas unit, right? I'm going to get a value count of gender. So there's 670 males and 273 females. And then I could build a data frame out of that, right? By, again, making a dictionary out of the index and out of the gender itself. And then I can display the data frame, and I can say gender plot pi. Plot is a function that is added onto the data frame by way of Matplotlib. Because I imported Matplotlib up here, this extends the functionality of the data frame so that it is now plottable. Okay, and I have to choose which value here is the y-axis, and the y-axis are the values that you're actually plotting, which are the counts. And then the MF comes from the index in the pie chart. Not from gender, it comes from the index. Okay? So that takes us to 1.1 code. And it says create a data frame and pie chart based on the age group. First create a series of value counts and then create a data frame out of the value counts. All right, so let's get going here. We have the, let's see here, the moviegoers data frame right there, right? So we're going to say goers and age group. I don't remember what columns I have. Let's take a look at those. There it is, age group. Age group. Value counts. There they are. And what I want to do is I want to build a data frame out of this. So I'm going to call this, I don't know, ages. Then we're going to call ages df, and we're going to build a data frame out of this. And we're going to say age counts. That's going to be my key. And my value is going to be ages. Building a dictionary out of that. There's my data frame. Okay, let's display the data frame. And then underneath the data frame, let's also display the pie chart. So that would be ages df plot pi. I want to see what happens when I just plot pi. I'm going to get an error that says it requires a y column. So it's saying you need to give me a y equals and then column. And then there you go. Again, I told you that these are not a column. This is the series names. So that's why the plot works. Now you see how it says axis, subplot, label, whatever? That's because I'm echoing the plot to the console. What I might want to do is use the display function instead. That way it hides that and just displays the outputs. Well, it still does it. That's interesting. Okay, so that, did it do it up here? Yeah, it did it up here too. Okay. Okay, so that is 1.1. So next thing that happens is we show you a pie chart where there's way too many values in the series. Okay, you don't want to have pie charts like this. Your pie chart should have 2 values, 3 values tops. So when you have a lot of series labels like this, we don't want to use a pie chart. We want to use a bar chart instead, because a bar chart allows us to see each label and then see its value, right? So this is a better indicator of values than a pie chart, which is very difficult to read. Okay, so now we're asking you to plot your age group as a bar. Okay, so let's see if we can do this. So it would be ages df plot bar. Let's just try that for starters. Oh, see, that works. Adult, youth, senior, right? In this case, I didn't have to put in any of the column names or anything like that. But if you're curious as to making it use column names, you can always get help on this, right? And it has an x-axis and a y-axis. Okay, so our y-axis in this case is what we want to deal with. And let's make our y-axis to be age group. Like that. I think it's age group. It's not age group. I forgot already. Check the columns again. Age counts. See, you got to know what this stuff is. It's good that I don't know, because then I can show you how you figure it out, which is important. Adult, youth, senior. Good. Okay. So that is 1.2 Ucode. Now, let's move on. There are times when you want to plot something and even a bar chart isn't sufficient. Look at this bar chart. You can't make any sense out of this, right? And that's because we are plotting individual ages. We are counting individual ages, and this is too granular of a category. So generally 2 to 3 categories, pie is good. A dozen categories to 15 categories, maybe a bar chart is good. Up to maybe a dozen categories. If you have more than a dozen categories and they're numerical in nature, you may want to think about bucketing them with what's called a histogram. A histogram is a way to take a series like age and get a count of all the different ages, 35, 40, 50, 20, 65, 14, and then put them into bins. Okay? So now what we're seeing here is there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins. And there are, about 200 moviegoers who fall into the range of 20 to 26. Okay, that is this bin here. You can change the number of bins by putting in a named argument into the hist function. So now I have 15 bins. See, the more bins, as the number of bins approaches infinity, you will have this plot again. The only difference is that this axis will be sorted by age. Okay, 70-year-olds over here, 10-year-olds over there. And to show you that, let's crank up the number of bins to like 25. See, there you go. This is a great way to present data that is numerical in nature. And because it's numerical in nature, there are way too many categories of it. There's way too many individual points of ages. And difficult to plot and represent. So write a one-liner to make a histogram of moviegoers with 7 bins and bar color cyan and edge color black. All right, so let's try this. So moviegoers, histogram, column is age. It doesn't make sense to pick a column that is not a numerical column when you're doing a histogram, because you can't bucket categories. Like if you're looking at counts of shopping products, like bananas, oranges, apples, how would you bin a banana and an apple together? You can't, right? But if you had total amount for each order, you could then say, let's count the amount of orders, the total amount on each order, and then let's bin them so that the ones that are similar go together. So column age, bins 7, and then we had a color of cyan, which is like blue-green, and an edge color of black. There we go. Again, it doesn't make sense to use a histogram unless the column you're plotting is a numerical value. So if I go back and look at goers one more time, that's 1-3, by the way. If I go back and look at it one more time, the only thing we could really use to bin by is age. Right? Even though zip code is a number, it's not a number that we add up or divide. There's no relationship between this being 15 and that being 43. Like, this zip code isn't greater than that zip code. That's not how zip codes work, right? But 24 is older than 23. Okay, so that's where the relationship matters. You can bin user IDs, but it wouldn't make any sense. I guess I could show you that just so you get an idea of how the histogram works. So maybe I want to do goers plot bar, and then I'm going to plot the Y as user ID. Okay, and I get this ridiculous looking plot. If it could even draw it, it might just be too much for it to draw. Let me see what I did up here. I need a... No, that's it, right? It's just crazy. There it is. It's like, what? It makes no sense, right? But maybe if I use a histogram, it would look better here. So let me try this as a histogram. I'm going to leave this here and say goers histogram. And I want to do column user ID. And let's do bins. Let's do 9 bins. I don't know why. I'm just going to pick 9. See what we get here. Cranking away. Takes a while because I also had the other bar. I should have commented this one out, right? I don't need to run that one. So this is what you get when you get a histogram of user ID. Why is it so flat like this? Because the data in user ID is just sequential. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is not like organic in nature. It is sort of made up, right? And so therefore it is evenly distributed. It is evenly distributed. And that's what a distribution of data looks like when it's evenly distributed. So it's a flat line. What makes histograms interesting is that they normally will follow some kind of bell curve, if you will, based on the data. Now, it might not look like a perfect bell curve, but it's going to be a seemingly close approximation of that. You should see this in like things like grades and things like that. You want to see like this hump in the middle where most people fall into the middle, and then there's outliers. There's not as many old people or young people, but there's a lot of people in the middle that go to the movies, right? Age-wise. So that's the point of a histogram. I thought I'd spend a little more time on that in case you don't have a statistical background, just to give you an idea of when a histogram would be used. Okay, now we're going to look at Plotly. Plotly is data visualization as a service. It helps to understand how Plotly works within the notebook. Every time you do a plot with Plotly, you are actually sending data to the cloud. The cloud draws the visualization, and then the visualization gets rendered in your Jupyter Notebook. So you might say, well, why would I want to do that? Well, they have some pretty nice data visualizations, and they tend to be somewhat interactive. So let me show you how it works, then I'll go over to Plotly and show you what's going on. So first you have to set up your credentials, your username, and your API key. You got to sign up if you haven't done it. I'll just change my key after the video's over. So you run that, that sets your credentials, and then you can now use your credentials to draw plots. And here I am drawing the same pie from before. You see it has a nice hover on it, gives you percentages, it figures that out automatically. You can click on things, etc. So it's a little more interactive, and you can take a screenshot, stuff like that. What's going on behind the scenes? So if you go into the Plotly dashboard, you can see your plots that it has generated. These are all the plots that Plotly makes. I can create a plot through here, and I can use, they have like a database that you can set up in here, or you can actually point it to data if you want. Like in this particular case, we are pointing it to a data frame right here, the gender data frame that we made from before. So most people will use Plotly through this interface, but we're actually using Plotly by never logging into this dashboard. Instead, we are just making visualizations in Jupyter that send them to Plotly and come back. If you reach your limit, like you run out of resources, then all you need to do is go in here and delete these plots. So if you go into this list and just check them all off and hit delete, that's okay. You're not going to hurt anything, because yes, you've deleted a bunch of plots. I don't know why it's not letting me. But you delete these plots, and you know what? It's no big deal, because the code that generates the plots is found in your Jupyter Notebook, and you'll always have that code in your Jupyter Notebook. Okay. So this is different than the way like a pointy-haired boss might use Plotly. The way we use Plotly is we write code that generates the Plotly, rather than going in here and doing create, chart. We're not doing that. Okay. So I run this again. Okay, regenerates my plot. I go in here and I go and look at recent, and it should show up in here at some point. Okay. All right. So that's basically Plotly. So let's fool around some more. So here's a bar chart in Plotly. Right. So I can see the bar chart. Kind of neat. You could zoom in. Like maybe I just want to see this bar. Zoom in. And you can double click and zoom back out again. Maybe. Is that to zoom out? Pan around. See that? It's kind of neat. Lots of different ways you can use Plotly. So let's try it out now. So what can you plot? If you do a dir on Plotly Express, you can find out all the different kinds of plots there are. Histogram, line, 3D line, scatter 3D. Is there a bar chart 3D? 3D bar chart? I don't see that. I see a bar polar. Some people think I'm bar polar. I wonder if I could try, let me try bar polar. Okay. Got unexpected keyword argument X. When you get this, that means you got to get help on bar polar so you can figure out how to use it. All right, got to comment this one out first. All right, and it says I need a data frame, and I need an R and a theta. I don't know. I need an R and a theta. I don't know. I don't know a lot about bar polars. Okay, but it just goes to show you there's lots of different ways that you can plot things here in Plotly Express. And you really just kind of have to read the instructions if you want to try different ones. But there's tons of plots that you can make in Plotly. And if you go to the docs, you can learn about all of them. I don't remember where the docs are. But it's somewhere in there. You can get these docs and examples of how to plot all of these different guys and gals in here. think it's in here. If I go here. And then docs, and then docs, and then here's the Python one. And these are all the things you can plot. Plotly Express is what we're using. Okay, polar charts. Oh, there's polar charts. Line polar. Let's see what that looks like. So that's what a line polar would look like. That's a scatter polar. I don't even know how to read these things, right? Anyway, but we can play around with those in a bit. Let's get to the actual thing we're trying to do here. It says, make a bar chart with the OCC data frame. Okay, so we want to do Plotly Express bar, and then my data frame is OCC data frame. And I forgot everything I need to know about the OCC data frame, so there they go. They have occupations. So one line of code is all that's required. Make a bar. Okay, so, and then I need to specify, I don't remember what I need to specify. Let's do help px bar. I need an x and a y, Okay, I could do that. I need an x. On the x-axis, I want to have on the y-axis, I know I want to have occupation. Let's see if that's enough. Do I need an x-axis? We'll figure it out. Okay. It got them all, but I don't think it's plotting this right because it's got the wrong counts. So maybe on the x-axis, let's see what we got here again. I want counts on the y-axis. I want counts on the y-axis, and I want occupation on the x-axis. That's probably what we want. There we go. So a lot of students, almost 200 students going to the movies. Doctors, not many students going to 7 doctors. 27 technicians, 45 writers. Okay. We educators obviously have a lot of time to go to the movies. 95 of us went. Okay. That is Plotly Express. One-liners, just like you did with plotting Matplotlib and pandas, you can do one-liners with Plotly Express. Okay, sometimes you need to plot, but you don't have a data frame, the data isn't in a data frame, you can't put it in a data frame, or there's some other limitation that requires you to not need or not be able to use the data frame. So here's how you use plain old Plotly. That is not Plotly Express, but just the Plotly environment. And let me just sort of break down what's happening here to help you understand it. So on a plot, on any plot that you make, there's something called a series, right? So this plot plots one series. On the canvas that you see, there's just one thing being plotted. It's occupations. Okay? If there were 2 series, I might be plotting occupation and age on the same canvas. Okay? I'm not doing that here. Okay? So you have to build a series, and when you build a series, you're going to build a series out of a graph object. Go is for graph object. Where does this come from, this go? Way up at the top here, we have we imported Plotly graph objects as go. See that? That's where that's coming from. So this works very similar to Plotly Express. The difference is there's no data frame. It doesn't assume that there's a data frame. So what you have to give it for an x and a y is a set of values, right? You're not going to just give it a column out of a data frame. You're going to give it an entire series. Again, plain old Plotly doesn't know anything about data frames. It only knows sets of data. So this could be a list. It doesn't have to be, a series out of a data frame. It could just be a list of anything. And I'll show you that in the next example. So then you create a figure, which is our canvas. Then you add the series that you want to trace. Then you configure what you want to label things, right? The x-axis title, the y-axis title, and then you ultimately show the figure. This is what you usually will send to IPython display. And then you get the plot. So this is like a custom plot. Okay. And you can plot more than one series this way, right? So you can make your figure. You can add one bar. You can add another bar. And then you can show that. Now there's 2 bars in this plot, right? So you can't really do that with Plotly Express. If you need to plot 2 different things on the same plot, you just need to add additional series. Now these can be anything you want. And I know we're getting into the 1.5U code, but let me do the 1.5U code, then I'll show you they can really be anything in the world that you want them to be. They don't have to be a data frame. Okay, so basically I want to take this information and I want to plot it. I want to make a line plot, or no, this is going to be a bar plot because occupation is not sequential, right? You would only use a line plot. There's no relationship between other and student. So why connect them with a line? If this was like January and then this was February, then it would make sense because, you know, January and February are related to draw a line. But it doesn't make sense to draw a line because these are categories. So obviously I want a bar chart. So let's make these. Let's call this series 1 is go bar. And I want to do the x-axis is going to be occupation. Occupation, and then the y-axis is going to be, the y-axis should be the counts, right? Then I want to add another series. I'm going to copy this. Whoops. I want to add another series here. And this series is going to be last year's counts. And now I need to build my canvas to do the plot. So I need to, let's call it figure, just make a joke, figure 8. And let's create a graph objects figure. And then I need to add my traces. So figure 8, add trace series 1. And then let's add series 2. Add series 2. Now I could set up the layout. I'm not gonna. We'll do that in a bit. And then let's do figure 8 show. Let's not set up the axis so you can see what we get here. Okay, I got a mistake here. It says module object is not callable. What did I do wrong? Oh, it's go bar with a capital B. So you gotta, right? Go bar with a capital B. Bar is a type. Okay, there we go. And there you go. You have student, other, educator, administrator, engineer, programmer, librarian, writer, and then you have last year, this year. And it says trace 0, trace 1, which are lame, right? So how do I name these traces, right? That's what I want to do is this go bar. I want to name these traces. So on add trace, I wonder if there's a way I can do that. So let's get help on add trace. Let's open up another window here. Let's do it above it. Help. This is how you learn. I mean, you just gotta, at this point in the course, you need to be able to start digging with your own shovel. Right? So it says add trace, row name, column name, secondary, exclude, empty, subplots, row, column. Row, column. Maybe it's going to be a row trace? Row? Or is it going to be column? I don't know. Let's try it out. Let's try it out. I don't know. Let's try it out. Let's try row. Row. Let's call this one counts. And then let's call this one row last year. Okay, it didn't like that. Value error. It's expecting something other than this kind of value is what it's telling me. That value sucks is what it's saying. What does it want? Let's see what it says here at the bottom. I love how it throws the help in my face. Let's see, what's it? Oh, does it throw the help in my face because I got help in here? No, I don't. All right, let's see what we got here. I know reading through a stack trace is not fun, but essential to learn how to do this. Did you mean R? Valid properties. DX, DY, error, hover, hover label, hover template. Is there just a label in here? Base. ID, hover text, inside text marker, meta, name. Oh, trace name. Let's try that. That seems like a good one to use. I don't know how I missed that one before. How about just calling it name? There we go. See that? Now I got the right trace names over there. Good. See, and that's great, you know, to learn. See, you can even filter these out. You know, I just want to see that trace or that trace. This is a great thing to do at this point in the class. Is sort of, you know, we can't teach everything. So you got to figure this stuff out, right? So that's how you add labels to a trace. Okay, now just to show you, you can plot anything. That's 1.5. We're done with 1.5, but let me just show you, you can plot anything this way. I'm going to copy this. I'm going to copy this. And I'm going to come down here. This way you don't have to watch so much typing. All right, and instead of plotting this bar, I'm going to say my x-axis has these numbers. 10, 25, 80, 35. And the y-axis is going to have, let's have, on the y-axis, let's put some months. Like, I'm sorry, this should be the x-axis. This should be the y-axis. And on the x-axis, let's put some months. Like January, February, March, and April. And we'll call this sales. Okay, I'm going to run this. And I screwed something up. I got a missing quote. So I'm missing a... There. So see, it has, you know, this and then this. It just combines it together, right? It doesn't look really appropriate. If you match the x-axis together, then it will supersede both plots over each other. So what I'm going to do now is I'm going to do a go scatter line. Can I do a line? Is there a line? I don't know if there's a go line. We'll try a line. I think it's scatter. And then I'm going to use the same x-axis. And then my y-axis here is going to be some different values. Like maybe I'm going to have, let's do this. Let's do 50, 45, 30, 15. We'll have it go downhill. And then we'll call this returns. Okay, and it's complaining about line. It's like, dude, there's no line here. So it's probably scatter. Okay, so it says I want scatter line, scatter dot line. Go scatter line. Try that. Okay, it doesn't like that either. Okay, so now it's time to get help. I don't know what I'm doing. So let's do a dir go. What kind of graph objects are out there? Okay, let's see. Is there a line? I don't see a line. There's a line in here. Go line. So let's get help on that. Help go line. Seems like there's a line. It's probably depreciate. It's depreciated. That's why. Okay, scatter. Okay, let's look at go scatter. Scatter. Okay. Scatter. Okay. Let's get a dir on GoScatter. It looks like it's got a bunch of functions in it. Okay. And there's a GoScatter line. Yeah, see, I thought so. So what did I do wrong there? I probably just didn't plot it right. Okay, let's get help on that. Help. Oh. Okay, I need a where's my yeah, I see line colors and stuff, but I don't see that. Hold on a second. All right, I figured it out. It's just GoScatter, and by default the scatter will use a line, but you can also have it just do a point if you want. But I just chose line. So here's what it looks like when you run it. So you've got this bar chart, and then the second series is just a line indicating the returns, right? And so that's how you can superimpose one chart over another using the manual version of Plotly or plain old Plotly. And you can see these are just lists. They don't have to be data frames at all. They can just be lists of data. Make it simple. Okay, that's 1.5. All right, the rest of the lab, there's no other coding activities, but let's talk about maps for a bit. So when you draw maps, you build a map, and then basically what you need to do is you need to loop over a data set, and each time add a marker. So you have to build a marker, and then after you build the marker, you add the marker to the map using the add child method of the map object. And then the final thing that you do is display the map, and then that puts items on a map. I got to run this cell first. Then that puts items on a map like this. See that? And there's a whole bunch of pins on this map, and you can tap each pin and see the data. Where does this data come from? That's called the marker, and it has a location, and that is where the pin goes, and the pop-up is the message, and this is the message. It's got age, year old, occupation from city, state. So 19-year-old male student from Marshall, Indiana. That's who went to the movies there in that data set. Okay. So that's building a map and adding pins. So what's neat about doing this is you can make an interaction out of this. So here's an example of me making an interaction. This is just a list of all the occupations. I'm feeding that into my function as input, and then based on your choice of occupation, I only map the pins for that occupation. So you can pick an occupation, artiste, and then hit run interact, and you get a map, and all these people are artists. Okay, maybe I want to take that map and I want to show programmers. Now this map has programmers on it. See that? I can go back to the map again and choose librarians. And now we get the librarians on the map. And that's how you build an interaction that uses a map. It's pretty simple. I mean, you build any interaction, it's just the output is now, instead of printing stuff, you have to use the display function to display the chart, the graph, the data frame, whatever you want. Here, you can display the data frame and the map if you want, right? So here's my data frame, filter data frame, right? So what I'm going to do is I'm going to take that, and I'm going to display that filter data frame and that map. So let's print out lawyer. There's the lawyer data frame. There's a lot. And then there's the map underneath it. Okay. There you go. Okay. So that's what's kind of neat about using these things in your project is you can build them as part of interactions and make them kind of fun and interesting. Okay. I know there's no code written there, but it's important to understand this code because you might want to use this kind of code in your project. Again, when you want to use a map, the approach is basically you must add each pin to the map. And you must build the marker pin first and then insert it into the map. And then you can only do that with a loop. Alrighty, that's it for this week's lesson on visualization. Bye now.